This question's asking us about margin of error. But before we get into the specifics of this question, let's talk about margin of error more generally. A sample study allows researchers to make an educated guess about a sample group. So just imagine this bar represents an entire sample group. Now, a sample study would take a tiny sliver of that group. So let's say this represents 100 out of 1,500 students at a school. If we sample these 100 students and find out that most of them would like a new cafeteria, then we can say it would make sense to assume that all the students at the school want a new cafeteria. But the bigger the proportion of the population that gets sampled, the better the guess, and essentially the lower the margin of error. So if we took this much of the population, now we'd be able to say with more certainty exactly what the student population's opinion is about whether or not they want a new cafeteria. As an extreme case, if you counted every single member of a population, you'd have no margin of error, allowing a claim with 100% certainty. So if I ask every single student at the school, do you want a new cafeteria? If I find out that 64% of the students at the school want the cafeteria, now I can say, I'm 100% sure that 64% of the students at the school want the cafeteria. That's definitely the case. But if you don't get the entire population, if you only sample a small sliver of a population, which is what is usually done, then you have a margin of error and you have to say what is likely to be the case, or what's plausible, or what seems reasonable to assume. So you're always going to see these wordings on margin of error questions. And that's what's happening here. We have this whole experiment being done, and some of the answers are telling us that plausible values for the average weight are between this number and this number. And if we didn't actually survey every single piece of data here, then we have to use a word like this. So just starting this question, A and B are overwhelmingly likely to be correct in this situation. So now getting a little more specific about this question, there's a lot of decoy information. The background is that the boxes will approximately have this many pounds, and 344 of the boxes are selected at random. So that's very similar to me saying earlier, if there are 1,500 students at a school and we're only going to survey 100 of them. So when the question says 344 boxes of oranges are selected at random, then we're imagining there must be thousands overall, and we're only taking a sample of 344 of them. And also, it really doesn't matter to us that this is an 8-hour period. It doesn't really have any bearing on anything. But the important thing here is that the average that was found after the study was 23.1 with a margin of error of 0.19. So on the high side, we could have a result of 23.29. That means we added 0.19. And on the low side, we could have a total of 22.91. That's 23.1 minus 0.19. So what are we saying? Based on the fact that we didn't count every single box of oranges in the company, we know that a plausible result for counting the amount of oranges in each box is somewhere between 22.91 and 23.29. And that's answer choice A, between these two numbers. And the way choice B is saying it is more unreasonable, because that one is saying that the plausible amounts are less than the 2291 or greater than the 2329. In other words, smaller than this or greater than that. And that's not what we want. What we want are numbers that are right in between these two values. So the answer here is A.